So today we're going to be looking at inverse trig functions. Now, if you remember what an inverse is, consider this. If I have the fraction 1 over 4, consider this. If I have the fraction 2 over 3, we would say the inverse of that fraction, denoted to the negative 1 power, is equal to 3 over 2. So essentially what an inverse does is it flips the numerator and the denominator in a fraction or a numerical value. It's not going to be very much different for trig functions. If you remember, Sohcahtoa was a very important acronym for us to remember. Sohcahtoa was essentially just a trick, nothing more, to remember that the opposite and the hypotenuse is going to be the ratio for the sine value, which is what the capital S is for. Sine is for the opposite over hypotenuse. Cosine is simply going to be adjacent over hypotenuse. And then tangent, the last one, is going to be opposite over adjacent. If you are unsure of what I'm talking about here, consider looking at my Intro to Trig Functions video. I'll put it in the top right corner right now. But assuming you have seen it or know what Sohcahtoa is and know what sine, cosine, and tangent are, this makes learning the inverse functions easier. And so over here I kind of created a table. It might be pretty beneficial for you to write that table down. And all it does is it shows you the 6 basic trig functions. We've dealt with these 3 on the left before, sine, cosine, and tangent. And we have new functions over here. So CSC, that is just cosecant. Cosecant is the inverse of sine. So since sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. And down here we have secant, denoted SEC, and that is the inverse of cosine. So since cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. And finally, if you're picking up on the pattern, maybe you see where this is going, but COT stands for cotangent. And cotangent is the inverse of tangent. So since tangent is opposite over adjacent, cotangent is going to be adjacent over opposite. So if I know how to find sine, cosine, and tangent of a triangle, I already know what cosecant, secant, and cotangent are going to be just by inverting those values. So let's look at an example. Here I have cosecant of A, and I want to find that. So since cosecant is the inverse of sine up here, then I can say that cosecant of A is going to be equal to the hypotenuse over the opposite. And so cosecant of A, hypotenuse over the opposite, we can see that the hypotenuse, let's do it, the hypotenuse in blue, it's always the longest side or the side across from the 90-degree angle. And it's going to be 10. And the opposite, let's do the opposite in red, opposite of A is going to be this mystery side right here. So we need to figure out what opposite of A is going to be. In order to do that, we need to use our Pythagorean Theorem. So since it's a right triangle, we know that A squared plus B squared is equal to C squared. So I'm going to go ahead and plug in the sides that I do have so that I can solve for the side that I don't have. And remember, A and B are the shorter legs in the triangle. So you can't write 10 for A or B because 10 is the hypotenuse, and the hypotenuse always has to occupy the C value in the Pythagorean theorem. So I can write this as A squared plus, and I'm going to say 8 is B. That's going to be one of the short legs. So 8 squared. And then 10 is going to be my C, which is going to be the hypotenuse. So c squared is going to be 10 squared. And now I can just do some algebra. I have a squared plus 64 equals 10 squared, which is 100. And so after I subtract 64 from both sides, 100 minus 64 turns out to be 36. So if a squared is equal to 36, well, after I square root both sides, a is just equal to 6, right? Because 6 squared is equal to 36. So that means that this side over here is equal to 6. And so now I can fill in my values. The cosecant of a is equal to the hypotenuse, which we already said is 10, over the opposite, which we just solved for, and that's equal to 6. Now before you circle your answer, we can break this down. There's a 2 in the top and the bottom, and if I divide the 2 out, this simplifies down into 5 over 3. So cosecant of a is equal to 5 over 3. Let's look at one more example. Okay, so we need to find the cotangent of m. We need to write our answer in rationalized form, which we'll get to that at the end. And cotangent, we remember, is the inverse of tangent, which means cotangent is always equal to the adjacent over the opposite. So if I look at m, since we're doing cotangent of m, the adjacent side is going to be 9, and the opposite is going to be the mystery side. It's going to be the mystery side. So adjacent, we already know what adjacent is. It's going to be 9. We just need to solve for the opposite side, which I don't know what it is, but we can solve for it if we use the Pythagorean Theorem. So a squared plus b squared is equal to c squared. And remember, c is always the hypotenuse here. So the hypotenuse, sometimes I just like to fill that one in first, just so I don't mix it up. Sometimes people accidentally write it as one of the legs, and that's going to throw off your calculation. You're not going to get a right answer. It's going to be frustrating. So write in the hypotenuse first, and then a squared plus b squared, well, 9 can go in for either one. I'll write it in for b. You could write it in for a. It'll come out to be the same. It's going to be 9 squared plus a squared, and I need to solve for what a is in order to find the missing side length. And so now this is a squared plus 81 is equal to, it should be equal to 2, the exponent. This exponent should be 2, not 3. And so now it's 6 times the square root of 3 squared. If you remember from algebra, you might remember that a times b squared is just a squared times b squared. So we're just going to distribute this exponent here. And now 6 squared turns into 36. Square root of 3 squared, that just is 3, right? The square root and squared undo each other. And so 36 times 3, if you punch that into your calculator, or if you know your mental math, that's 108. And so that means that a squared is equal to 108 minus 81 from both sides. And that's going to be 27. So a squared is equal to 27, which means a is equal to the square root of 27. And so I can simplify this down a little bit further. If you're not sure how to do that, I'll go ahead and put a quick video up in the top right corner for you to refresh yourself. But I can simplify this down into, since this is 3 times 3 times 3 in its prime factored form, I can factor out 2 of the 3's, and it's going to become 3 times the square root of 3. So a is equal to 3 times the square root of 3. So we now have what we need. Cotangent of m, it's the adjacent over the opposite here. So my adjacent we already know is 9. The opposite is 3 times the square root of 3. We just solved for that. And now I need to make sure I simplify this down. So 9 and 3 can for sure simplify down. to get me 3 over the square root of 3. But remember, we need this in rationalized form, which means that we cannot have any square roots in the denominator. I made a short video on how to rationalize if you need a refresher. I'll put that in the top right corner right now. Go check that out. It'll be very helpful if you're not sure how to do this. And so what we're going to do is we're going to rationalize this by multiplying top and bottom by the square root of 3. And so this turns out to become 3 times the square root of 3 over square root of 3 times square root of 3 is just 3. And then the 3's cancel, or simplify to 1 over 1, which leaves my final value as the square root of 3. So in conclusion, cotangent of m is just equal to the square root of 3. And that is my answer.